another problem similar to the previous one in which we will apply first law of thermodynamics, and that is a kind of closed system as well. I give you 30 seconds to read the statement of this problem 2.26 given in your book. I give you 30 seconds. Please read this statement. Make a solution strategy in your mind, and then we will solve this problem together. All right. I hope you have gone through this statement, which is a 5 kilogram aluminum. 5 kilogram is mass. Mass is how much? 5 kilogram of aluminum, right? Block sits in your lab, which is at 21 degrees Celsius. How much? 21 degrees Celsius. So we can say simply T1 is equal to 21 degrees Celsius, and we can convert that into Kelvin, and which will become 294 Kelvin. Okay. Now you wish to increase the temperature of the block to 50 degrees Celsius, mean it's heating, right? It's heating. So now you want to raise this temperature of this block from T1 to T2, which is how much? 50 degrees Celsius. And if we convert that into Kelvin, that becomes 323 Kelvin. Okay. Now we need to calculate, because when this is the mass and this is the temperature is increasing from T1, which is 21 degrees Celsius, to T2, which is 50 degrees Celsius. We need to calculate how much heat in joule is supplied. How much is this heat is supplied to heat from T1 to T2. Now the question should come in mind, is there any phase change involved in this process? Because if there is a phase change involved in a process, then we need latent heat. But if phase is the same, which is solid, phase is not changing in this process. So if phase is the same, then that means that is a sensible heat, right? And for sensible heat, and to calculate sensible heat, we have a specific formula, which is Q is equal to mCp delta T. Q is sensible heat, M is mass, Cp is heat capacity, and delta T is temperature difference, T2 minus T1. So this formula can also be written as number of mole Cp delta T. In this case, Cp unit is per unit mass. In this case, Cp unit is per unit mole, right? So that's the difference. Temperature is Kelvin, mass is in kilogram, number of moles. So all these are units, right? Now, how I know that this is a sensible heat? The easiest clue for that thing is because temperature is changing. And you know that if temperature is changing, that is a sensible heat. And if temperature is constant, and that means phase change may happen, and that's a latent heat. We have different formula for calculation of the latent heat, but for sensible heat, we have this formula, which I have written here, right? Now, Applying first law of thermodynamics, Q plus W is equal to delta U, right? This is the first law of thermodynamics. But we have solid. Solid, like say for example, this is solid. Now this is not moving up and down, right? So this is not a moving pistons or a rising piston cylinder arrangement or rotating shaft arrangement. It's still solid, right? No work, it's not moving an up and down. So that's why work done is 0. So that means Q becomes equal to delta U, right, for this system. And Q is equal to NCP delta T as we said here, right? Okay. Now, can we calculate the amount of heat in joule that needs to be supplied to increase temperature for T1 to T2? This is the formula. First, we need number of moles. Number of moles equal to mass over molecular weight. How much is mass? We have 5 kilogram. Molecular weight of aluminium is 26.98. M is 26.98 gram per mole. Now if we convert this into kilogram per mole, so it becomes 0.02698, right? So that's why it's a conversion, because we have mass in kilograms. So we have mass, which is 5 kilogram, and molecular weight after converting this gram per mole into kilogram per mole. We got number of moles because kilogram cancels, so we got moles, right? So that means N is done. Now CP is normally written as R into A plus BT plus so on, right? Like this in different books. So this is R. So this is number of moles. This is R. This is A, coefficient for calculating CP. This is B, and this is temperature, and temperature range is given as well. You will solve these numbers, and these A and B, you know that these are normally given in appendix. You can see your textbook, or you can also see your 205 book as well. For aluminium, remember, not look for aluminium liquid. Aluminium, it's an aluminium solid. So please look for A, B, and C for aluminium solid. Then you will get this A and B, and after solving this, you will get this amount of heat in kilojoule. In other words, we need this much amount of heat to raise the temperature of this 5 kilogram aluminium from T1 to T2, which is 21 degrees Celsius to 50 degrees Celsius. I hope this problem is clear to you, and this is again an application of first law of thermodynamics, more or less for closed systems. Okay.